Hi, and welcome to Concepts for Thinking. I'm Bree, and today I'm going to be talking about confabulation, confirmation bias, and creaky doors. Creaky doors is a metaphor that I've taken from a comedian, Brian Regan, who he tells this joke, which is a story about people who are investigating whale calls and trying to decipher them and figure out a kind of whale language. And the joke, I'm not gonna try to make it funny, but basically he's talking about these researchers, picturing them sitting in a boat, listening to the whales and writing down what they think they're saying. And he's like, well, wouldn't it be funny if they did all this work for all these years and it turned out they were listening to like a creaky door behind them? And he makes it sound funny. But I think about this actually all the time because even though, of course, there's no chance that that's happening in that case, throughout science in various fields, there are constantly cases where we're measuring something, we think something is meaningful, and it turns out we're over-interpreting something that's completely meaningless. And I could think of a billion examples, but one that comes to mind is there was a postdoc at Emory where I was kind of hanging out with some psychologists working in a lab, and this postdoc in another lab did a presentation about intranasal oxytocin studies that were, at the time, there are a lot of studies using intranasal oxytocin. That means they're putting this molecule into humans and animals and seeing if oxytocin is known for being involved in social bonding, especially maternal relationships and with children. And they're seeing if there's an effect if you administer oxytocin intranasally, that is through the nose, if you'll have these changes in how people interact in various circumstances and also animal paradigms. And what he said is, in his presentation, there's all this research, and yet recently, they had basically shown that there's very little likelihood that intranasal oxytocin ever got into the brain. So what that means is, well, at least in humans, I think it was maybe different in rodents. What that means is all these human trials that have been showing findings were based on absolutely nothing. If that was the case, there was no oxytocin, and so all the findings that you could explain in terms of people doing a lot of comparisons experimentally, and as soon as they found something that looked to be statistically significant, they submitted that as a paper. If they didn't find anything, maybe they just never published it, or there's like a lot of ways in which you can make a finding out of really noise. And so I thought that was an interesting example. Another example is I was doing some fMRI brain imaging work, and in that field there's a problem called reverse inference, where you see activity in a particular region and you think that actually I talked about this in the spurious correlation video. You think that there's a particular meaning, someone's performing an action, you see activity in a region of the brain, you think that region of the brain can be defined in terms of that action, or it's involved in that action. But that really may not be the case at all. It may not be doing anything related to the action. And an analogy I think of is, let's say you were to look at muscle activity and someone's typing on their computer, and while they're typing they have a twitch in their eye, or they are tapping their toes or something like that, and if you were to scan their body, you might think that the toe tapping was involved in the typing, but of course it's just a spurious correlation. So there are a lot of studies in neuroscience that are just based on nothing, just problems with reverse inference. And this can be even worse. There's another problem in fMRI data, which is that you have so many comparisons, you're looking at so many voxels of the brain, that you can, there's just by random chance, you're gonna see some activity. And so you can have activity that's just completely noise. And it's not even a spurious correlation, it's just, you know, just completely coming out of nowhere. So there was a study where a group of researchers put a dead fish in an fMRI scanner, and they found voxels in the fish brain. They were active during one task relative to another task, and of course it was just to prove that you have to do some corrections to account for, this possibility that you're going to be interpreting noise. So this creaky door problem is something I think about a lot, and it can happen in science, and it can happen just in everyday conversations and arguments. And I thought I would just share a story that happened to me recently, because it's an embarrassing story, but I think it's illustrative of this creaky door phenomenon and of a couple of other concepts that I wanted to cover. So the concepts are confabulation and confirmation bias. We touched on confirmation bias before, and this is going to be an example. I touched on it in the cherry picking video, so the last one. And now I'm going to give a story that shows that even though I know about confirmation bias, I'm totally guilty of it, just like everyone else. So I got into a little Twitter argument with some influencer who I follow, who had posted something I didn't agree with, and I wasn't trying to be a jerk, but I wanted to sort of call him out, hold him to account for saying something that I had a problem with. And he was looking at COVID deaths data, and he had posted an image and made basically this claim about the data he had posted. And I commented and was like, you know better than this. This is not the right interpretation of the data. And I agreed basically to follow back in a month and look at how the trend went, because he had sort of made a prediction, and see who was right. And as the month went on, I was thinking about it and seeing that I was right. Basically, over time, the trend went in the direction I had predicted, and I just waited the month, and then I posted the figure a month later. And immediately after I posted, he responded back, WTF, posted a different figure. And it turned out that he had been posting data on COVID deaths in New York City. And I had assumed and thought that he was posting data on COVID deaths in the US. And they're a very different figure. I mean, it's really hard to imagine looking at that New York City data and thinking it's for the US, because it's a really different image. But somehow it just hadn't crossed my mind. So confirmation bias, for a refresher, confirmation bias is when your prejudice or your expectation makes you sort of sensitive and attuned to certain data that confirms what you already are thinking, and sort of dismissive or blind to data that disconfirms what you're thinking. And it can be prejudice, it can be because you're sort of ideological or something, but it could also just be expectations. If you expect to see something and the reality is different from that, you might just not even notice. And that happens all the time. And that's what happened in this case. It's kind of embarrassing, but I mean, for me, it was actually very embarrassing. But I had just totally thought the wrong thing. I had confirmation bias. And so at this point, actually, it had become kind of combative. Especially this guy's followers had kind of jumped on me and called me names and stuff. And so I was in a reactive state. So at that moment, I had an opportunity. What I should have done is immediately said, I'm sorry, I can't believe I made this mistake, and I just apologized and had done with it. But in that moment, I was kind of, my ego was threatened. I was in this situation of facing embarrassment, and I decided to double down. So instead of admitting my error, I tried to and this was kind of intuitive. I almost didn't think about it, but sort of play it off as if I had made a sort of reasonable inference based on other things he had said, that he was actually talking about US data, and so kind of doubled down on that statement. And so that's what I did. And it actually took me a couple hours to rethink that and go back and correct the record. But what that is called, what I did, is called confabulation. Confabulation is when you make up a story after the fact to sort of justify yourself, and it's not a true story necessarily, but it's just a story that's convenient. And we do this all the time. In my case, it was knowing confabulation to some extent, but not entirely. It happened so fast that I almost believed it. But it can be entirely unconscious, and there are some interesting studies that illustrate this. Probably the most famous, there's a Nobel Prize involved in this, is these split brain patients. So you may know that the human brain has two lobes, the left and the right, and they're connected by something called a corpus callosum. It's like in the middle, it's this flat sheet of neurons, and it allows your left and your right brain to communicate with each other. But a while back, a surgeon did something for patients who are suffering from epilepsy, like really extreme, constant bouts of epilepsy. He realized that it might be possible to save these patients from epilepsy by cutting the corpus callosum. It would reduce the kind of activity in the brain that was causing these epileptic fits. So he cut some of these brain corpus callosi, I don't know if that's how you say it, but he cut them. And so these patients had divided brains. They had two different lobes. And they did all these interesting experiments, some of which sort of suggested that they had essentially created two distinct subjectivities without communication between them. And there's been some challenge to that recently, so I don't want to say that that's necessarily true. But some of the experiments they did that were relevant to this discussion of confabulation is they would do things like, so you may also know that the left brain is in charge of language. So the right brain is not able to speak, but your left brain can. And so they would do experiments where they would show something, and you also may know that your left eye is connected to the right brain, the right eye is connected to the left brain. So it creates this very convenient paradigm for investigating how the two sides of the brain work. And they would do experiments where you would show the left eye connected to the right brain something, but not the right eye. And so the right brain knew something and was able to act. The body was able to act, but it couldn't say what it knew. And so they would have something happen where the left hand connected to the right brain would reach into it would act based on what it knew. And then they would ask the person, why did you do that? And of course, the left brain had no idea what the right brain knew. And so the left brain actually could not answer that question of why the body had just done what it did. And you might think that the person would then say, I don't know why I did the thing that I did. But turns out that a lot of the time, the person would make up an explanation that had nothing to do with the real explanation. The real explanation was always really obvious and pronounced because the right eye had seen whatever it needed to see, and that's why the person was able to perform the task. But because the left brain didn't know that, it would just make up some totally random explanation for why the person had done what they had done. And that is a confabulation. That is when you make up a story that really isn't based in reality. It's based in sort of some desire to make sense of the world, to defend your ego, as in my case, or something like that. So to conclude my story, yes, what I did was I confabulated for a couple tweets, and then thought about it for a couple hours, felt bad, decided, the world would be a lot better. I know this, and I hope we all know this. The world would be a lot better place if we were able to admit our errors, even when it's hard, even when people have insulted us. And so then I went back and apologized and admitted my mistake, and waited a day, and then went back and deleted all my tweets on that thread. So that's my embarrassing story about both falling prey to confirmation bias and confabulation. And also, I'm just hoping that this idea of a creaky door is useful, that you start to realize that there are many cases where you might think that you're interpreting something properly, and you're just not. You're just responding, you're just making up a story based on data that fit with your biases or pre-existing beliefs or what you want to think. And that's a very normal, common thing. And the more aware, even though I'm aware of this, I still did it. But I was at least able to recognize eventually that what I had done and go back and apologize. And I think that is an important thing to do, like to recognize that we make errors and that it's okay. It's not the end of the world that we've made an error, but it is important to acknowledge the errors and to change our behavior, to change our minds when we're wrong. I hope this has been helpful, and take care.